Look up into the night sky on the clearest of evenings, far from the glare of city lights that veil the cosmos. What you witness is a serene, silent, and seemingly eternal spectacle, a velvet black canvas, punctured by the steady light of a few thousand stars. It feels knowable, perhaps even intimate. This is our celestial neighborhood, our home in the grand scheme of things. For millennia, this was the entirety of our perceived universe. A dome of familiar constellations, a wandering moon, and the comforting ribbon of the Milky Way. But this comforting view, this tranquil celestial sphere, is a profound illusion. It is a veil of cosmic modesty, hiding a truth so staggering, so incomprehensibly vast, that it fundamentally shatters our sense of place. We believed we were looking out at an ocean dotted with islands of light. The reality is something else entirely. We are adrift in a single drop of water in an ocean of oceans, a cosmic expanse teeming with not thousands, not millions, not even billions, but potentially trillions of distinct galaxies. Our journey to this mind-altering realization did not happen overnight. It is a story of human curiosity, of technological ingenuity, and of the relentless courage to question everything we thought we knew. It began with faint, fuzzy patches of light in the sky, smudges that frustrated early astronomers. In the 18th century, the French astronomer Charles Messier, a dedicated comet hunter, found these stationary blurs to be a nuisance. They looked like comets but never moved. To avoid mistaking them for his true quarry, he began to catalogue them, listing their positions so other astronomers could ignore them. He labelled the smudge in the constellation Andromeda as M31. Another, a beautiful spiral, became M51. Little did he know, his catalogue of celestial annoyances would one day become a guide to the most glorious structures in the universe. For over a century, the nature of these spiral nebulae remained a mystery. Were they nascent solar systems forming within our own Milky Way, or were they something far, far grander? The question culminated in one of science's great public confrontations, the Great Debate of 1920. On one side stood Harlow Shapley, who argued these nebulae were local gas clouds. He had measured the size of our Milky Way and found it to be immense, far larger than previously thought. To him, it was inconceivable that these smudges could be comparable structures, as their distances would have to be astronomical, making the universe impossibly large. On the other side was Heber Curtis, who championed the island universe's hypothesis. He contended that these were indeed entire galaxies, just like our own, lying at unfathomable distances across an enormous void. The debate was passionate, built on the best evidence of the day, but it remained unresolved. Science needed a new tool, a new messenger from the cosmos, to settle the dispute. The answer would come from the cold, clear nights at the Mount Wilson Observatory in California, and from the patient eye of an astronomer named Edwin Hubble. Hubble was using the colossal 100-inch Hooker telescope, the most powerful of its time. He aimed it at Messier's old annoyance, M31, the Andromeda Nebula. Night after night, he captured photographic plates of this celestial haze, searching for something that could unlock its secrets. And then, he found it. Among the swirling arms of light, he identified a specific type of star, a Cepheid variable. These stars are extraordinary. They are cosmic lighthouses. Their intrinsic brightness is directly linked to the rhythm of their pulsation. By measuring how fast a Cepheid brightens and dims, an astronomer can calculate how bright it truly is. And by comparing its true luminosity to how dim it appears from Earth, one can calculate its distance with astonishing precision. It is like seeing a 100-watt light bulb in the distance. Because you know its actual wattage, you can determine how far away it must be, based on how faint it looks. Hubble performed the calculations. His hand must have trembled. The Cepheid star, and by extension the entire Andromeda Nebula, was located nearly 1 million light-years away. This was a distance that dwarfed even Shapley's enormous estimate of the Milky Way's size. Andromeda was not a cloud within our galaxy. It was a separate, majestic island universe appear to our own Milky Way. In that moment, the known universe expanded in an instant, a billionfold. The sky was not a single kingdom of stars, it was an empire of empires. Humanity was suddenly and irrevocably demoted. We were not the center of existence, we were residents of one stellar metropolis, among a growing list of others. Hubble and his successors continued the cosmic census. They pointed their telescopes across the sky, finding more and more of these island universes. They came in beautiful and varied forms, majestic spirals, great elliptical spheres of ancient stars, and chaotic, irregular agglomerations. Each was a gravitationally bound city of hundreds of billions of suns, each star a potential anchor for planets, for life, for civilizations. By the mid-20th century, the number of known galaxies had swelled to the thousands, then to the millions. With the advent of more powerful telescopes, our view became deeper and the cosmic population exploded. The universe was beginning to feel crowded, teeming with these stellar systems, and yet we were only seeing the brightest and the closest. We were like someone standing on a coastline at night, seeing the brilliant lights of a few major port cities across the water, completely unaware of the countless smaller towns and villages hidden in the darkness beyond. To see those, we would need a new kind of vision. We needed to stare into the abyss, to look longer and deeper than anyone had ever dared before. That moment arrived in 1995 with the Hubble Space Telescope. A group of astronomers, led by Robert Williams, decided to conduct a radical experiment. They would point the magnificent orbital observatory at a patch of sky so dark, so seemingly empty, that it was devoid of any known stars or galaxies. The chosen spot, in the constellation Ursa Major, was minuscule, equivalent to the size of a grain of sand held at arm's length. For 10 consecutive days, over 100 hours of precious observation time, the telescope collected the faintest whispers of light from this barren celestial window. It was a tremendous gamble. Many in the astronomical community thought it was a waste of resources. What if, after all that time, the resulting image was simply black? But when the data was compiled and the image was finally rendered, the result was not blackness. It was a revelation that silenced all critics and forever changed our perception of the cosmos. The image, which became known as the Hubble Deep Field, was an explosion of light and color. That tiny, insignificant, empty patch of sky was not empty at all. It was filled, wall to wall, with galaxies. Nearly 3,000 of them were captured in this single, microscopic pinprick of the heavens. They were not the grand, well-defined spirals of our local neighborhood. These were phantoms from the dawn of time. Some were distorted, misshapen, caught in the act of colliding and merging. Others were faint red smudges, their light having traveled for over 12 billion years to reach us, carrying images of the universe as it was in its infancy. The Hubble Deep Field was a core sample drilled through cosmic history. Each speck of light was an entire galaxy, a city of 100 billion suns receding back to the dawn of creation. Imagine walking onto a vast, dark beach at night. You pick up a single grain of sand and place it on a black cloth. You then look at that single grain through a super-powered microscope. Instead of seeing a simple mineral structure, you discover that the grain of sand itself is teeming with 3,000 unique, vibrant, and complex microscopic cities, each with its own history and structure. Now, consider that the entire beach, stretching for miles in every direction, and all the beaches on the entire planet, are also made of these grains. That is the philosophical vertigo induced by the Hubble Deep Field. If that one tiny spot in the sky held 3,000 galaxies, how many must there be across the entire celestial sphere? A simple calculation provided a staggering answer. By multiplying the number of galaxies in that tiny field by the number of such fields it would take to cover the whole sky, astronomers arrived at a new cosmic census. At least 100 billion galaxies in the observable universe. Perhaps even 200 billion. For a generation, this became the accepted number. 100 billion galaxies, each with 100 billion stars. The scale was already beyond human comprehension, a number that sat on the edge of meaning. We felt we had finally grasped the sheer magnitude of our cosmic home. But the universe, it turned out, was hiding an even more profound secret. The true number was far, far greater. The leap from 200 billion to trillions came from a new way of thinking, a synthesis of deep observation and sophisticated computer modeling. An international team of astronomers, led by Christopher Consolis, embarked on a project to create a three-dimensional map of the universe through time. They understood that looking far away in space is also looking back in time. A galaxy 10 billion light-years away is seen as it was 10 billion years ago. They painstakingly gathered images from Hubble and other observatories, data that represented different epochs of cosmic history. They then converted these flat images into a 3D model, allowing them to count the number of galaxies present at each stage of the universe's evolution. What they discovered was a stunning cosmic narrative of creation and destruction. In the early universe, just 1 billion years or so after the Big Bang, the cosmos was a much more crowded and chaotic place. The universe was smaller, and matter was more densely packed. Instead of large, majestic galaxies, there were countless smaller, proto-galactic fragments. These were scrappy, infant galaxies, blazing with the brilliant blue light of young, massive stars. The early universe was teeming with them. Their models showed that, at this early epoch, there were at least 10 times more galaxies, perhaps even 20 times more than we see today. So where did they all go? The answer lies in the relentless, creative, destructive force of gravity. Over the subsequent eons, these smaller galaxies were drawn together. They collided, they merged, they cannibalized one another in a colossal, billion-year-long process of galactic consolidation. Our own Milky Way is a product of this history, a composite being, built from the remnants of dozens, if not hundreds, of smaller galaxies it has absorbed. Andromeda is doing the same. This process continues even today. The large, stable galaxies we see in the modern universe are the survivors, the amalgamated victors of an ancient cosmic battle royale. The vast majority of the primordial galaxies are now gone, their stars and gas integrated into the colossal structures we witness. This realization presented a profound challenge. The Hubble telescope, as powerful as it is, can only detect the brightest of these ancient, distant galaxies. The vast majority of those smaller, fainter, primordial galaxies are simply beyond its reach. Their light is too dim, stretched and redshifted into oblivion by cosmic expansion. They are effectively invisible to us. They are the ghost galaxies of the past. The team then performed the final, mind-bending calculation. They knew how many galaxies existed in the early universe based on their models. They knew how many of these we are unable to see with current technology. When they added the visible galaxies to the inferred population of invisible ghost galaxies, the total number was astronomical. The universe, across its entire history, has likely been home to at least 2 trillion galaxies. 2 trillion island universes. Let that number settle. Not 200 billion. 2 trillion, a tenfold increase in the sheer scale of everything. It means that for every single galaxy we can currently detect with our most powerful instruments, there are at least 9 others lurking out there in the darkness, their ancient light too faint for us to ever receive. The visible universe we have so proudly catalogued represents a mere 10% of the total galactic population. 90% of all galaxies that have ever existed are currently hidden from our view. Our cosmic census was off by an order of magnitude. The universe is not just bigger than we imagined, it is more populous, more complex, and more mysterious than we ever dared to believe. This discovery does more than just inflate a number. It reframes our entire understanding of the cosmos's structure and evolution. These trillions of galaxies are not scattered randomly like dust motes in a sunbeam. They are organized. On the grandest scales, the universe is structured like a colossal, shimmering web. Vast, interconnected filaments of dark matter, the invisible scaffolding of the cosmos, stretch for hundreds of millions of light years across the void. Galaxies and galaxy clusters congregate along these filaments, like beads of dew strung along an immense spider's web. They flow along these cosmic superhighways, drawn toward the most massive intersections, the great galactic superclusters. In between these glowing filaments are the great cosmic voids, unfathomably vast regions of near-perfect emptiness, some so large that they would take light hundreds of millions of years to cross. Our universe is a tapestry of luminous filaments and dark voids, a celestial nervous system where trillions of galaxies are the synapses, firing with the light of countless stars. And our own Milky Way is but one small component in one filament, part of the Laniakea supercluster, a name which in Hawaiian means immeasurable heaven. The truth of 2 trillion galaxies also deepens the most profound enigma in all of science, the mystery of dark matter and dark energy. The visible matter that constitutes these trillions of galaxies, all the stars, planets, gas, and dust within them, amounts to a shockingly small fraction of the universe's total mass-energy budget. All of it, every sun, every nebula, every quasar, accounts for a mere 5%. Roughly 27% is thought to be dark matter, the aforementioned invisible substance whose gravity sculpts the cosmic web and holds the galaxies themselves together. Without it, galaxies would fly apart, their stars flung into the intergalactic void. The remaining 68% is even more bizarre: dark energy. This is a mysterious, repulsive force, an inherent property of space-time itself, that is causing the expansion of the universe to accelerate. It is pushing all of these trillions of galaxies away from each other at an ever-increasing rate. So, the mind-bending truth is not just that there are trillions of galaxies, but that these trillions of luminous structures are merely the foam on the surface of a vast, dark, and utterly inscrutable cosmic ocean. They are the visible markers of a universe whose fundamental nature remains almost entirely unknown to us. This cosmic immensity, this sea of 2 trillion stellar realms, inevitably brings us to the most personal and existential of questions. Are we alone? Let us attempt to grapple with the new numbers. If we take a conservative estimate of 1 trillion galaxies and assume an average of 100 billion stars per galaxy, we arrive at 100 sextillion stars in the observable universe. That is a 1 followed by 23 zeros. This number is so large it defies all terrestrial analogy. It is more than all the sounds and words ever uttered by every human who has ever lived. It is, by some estimates, more than the number of grains of sand on all the beaches of Earth. Now, consider the planets. Recent discoveries have shown that planets are not the exception, but the rule. It is likely that most stars host planetary systems. Let us be conservative again and assume there is, on average, just 1 planet per star. That gives us 100 sextillion planets. How many of those might be like Earth? How many might orbit their star in the habitable zone, that temperate region where liquid water, a key ingredient for life as we know it, could exist? Even if this fraction is minuscule, say 1 in a million, we are still left with 100 quadrillion potentially habitable planets. 100,000 trillion worlds where the conditions for life could be met. With such odds, it feels like a mathematical certainty that life should be abundant. The universe should be teeming with it, a cosmic chorus of biology in all its forms. Some of that life should have evolved intelligence. Some of that intelligence should have developed technology and reached for the stars. Our galaxy alone, a single entity among trillions, should be home to numerous advanced civilizations. And yet, when we turn our radio telescopes to the heavens, we are met with a profound, unbroken, and deeply unsettling silence. This is the great Fermi paradox, the stark contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. Where is everybody? The existence of 2 trillion galaxies makes this silence even louder, more deafening. The cosmic stage is exponentially larger than we thought, but the actors are nowhere to be found. Perhaps civilizations are incredibly rare, arising only through an impossibly long and improbable chain of cosmic and biological flukes. Perhaps there is a great filter, some inevitable catastrophic event or technological bottleneck that prevents intelligent life from becoming interstellar. Or perhaps, in a more unnerving scenario, the universe is a dark forest and wise civilizations know to remain silent lest they draw the attention of cosmic predators. Whatever the answer, the multiplication of worlds from billions to trillions transforms the Fermi paradox from a curious puzzle into a haunting, existential enigma. It places our own existence in a far starker context. We may be living in an age of cosmic miracles, a brief flicker of consciousness in an otherwise sleeping and desolate universe. And what of the far future? What is the ultimate fate of this vast cosmic archipelago? The discovery of accelerating expansion driven by dark energy paints a dramatic, if melancholic, final chapter. The galaxies are not just moving apart, they are flying away from each other at an ever-increasing velocity. In the distant future, this acceleration will have profound consequences. Galaxies beyond our local group, our small cluster of gravitationally bound neighbors, will eventually recede from us faster than the speed of light. This does not violate Einstein's theory of relativity, as it is space itself that is expanding. Their light will be stretched so severely that it will never be able to reach us. One by one, they will disappear from our sky. They will cross over a cosmic event horizon, forever beyond our sight and contact. Future astronomers, trillions of years from now, will look out from our merged Milky Way Andromeda galaxy, now called Milkomeda, and they will see nothing but an endless, featureless void. All evidence of the other trillions of galaxies, of the Big Bang, of cosmic expansion itself, will have been erased by the inexorable stretch of space-time. They will inhabit a universe that looks static and empty, believing themselves to be utterly alone in a single island of light. We, today, are living in a privileged epoch, a brief, fleeting moment in the universe's long history where we can still see the evidence of our cosmic origins and the true, staggering scale of reality. We are the generation that can still witness the grand cosmic narrative in its full glory before the curtain of dark energy falls for good. So we are left here, on our small blue world, armed with this perilous knowledge. The sky we see at night is a lie, a beautiful, comforting deception. Beyond that veil of darkness lies a universe of nearly unimaginable scope and complexity, a cosmos containing trillions of galaxies, 90% of which remain invisible to us. We are inhabitants of one stellar city among trillions, a city built from the wreckage of countless smaller systems that came before. This entire luminous structure is but a whisper of froth on an ocean of cosmic darkness. And this vast, populated universe is, as far as we can tell, completely silent. This is the mind-bending truth. It does not make us insignificant. Instead, it imbues our existence with a profound and startling significance. In a universe of such scale, our consciousness, our ability to wonder, to build telescopes and decipher the light from ancient galaxies, is the most precious and perhaps the rarest phenomenon of all. We are the universe's way of knowing itself. The journey from a few fuzzy nebulae to a cosmos of 2 trillion galaxies is the story of our own expanding awareness. And as we continue to gaze into the deep, we must confront the possibility that the eyes staring back are, for now, only our own. The cosmos awaits in all its silent, terrifying, and majestic grandeur, and our exploration of it has only just begun.